Everyone, welcome to the Unit 3 semester review. This is going to be over absolute value type functions. So with this first question right here, given the graph, identify the following information. Where's the vertex? Vertex is the highest or the lowest point, so that's 1, 2, 3 over to the left, and 2 down. And if you notice the function, plus 3 on the inside would make you go 3 left, and minus 2 on the outside would make you go 2 down. So just something to point out. So it's at -3, -2. Remember, the axis of symmetry is the x-coordinate of the vertex. X, axis, axis, x. So x equals -3. Is this a max or a min value? Is this the highest or the lowest point? It's the lowest point. Everything's going up after that. So I'm going to circle a min, and then I'm going to write y equals -2, because you just take the y value of the vertex. So the domain of any absolute value function is all real numbers, unless the domain is restricted, which you'll see it restricted like on number 2, but we'll get there. But see how number 2 doesn't go on. So if you see the graphs going off, then you know it's definitely not restricted like it is on this one. So that can be all real numbers or -infinity to positive infinity. They both have to be in parentheses. Now the range, the lowest point was -2, right? And then it went up. So it went from -2 to positive infinity. -2 has to be in a bracket because it touched it, but you can't touch infinity. You could also write it as y is greater than or equal to -2. All right? So that's number 1. With number 2, it just identify the domain and range, but you have a clearly restricted domain because you have these points that make it start and stop. So the domain is going from -4 to 0. Don't look at the -1. That's the tricky part. See the -1, you think, oh, it's going from -4 to -1. Remember, domain's just left to right, so -4 to 0. So I'll put D, and then I'll put -4, comma 0. Both of those need to be in brackets because it's touching -4 and 0. You could also write that x is in between -4 and 0. So when you do that with the inequality signs, they both point to the left and x goes in the middle. And then you underline both because they're both touching. So the range, what's the range going to look like? Let me draw an R here. Oh, I accidentally changed colors. All right, so the range. Let's see here. What's the lowest point? -3. What's the highest point? -1. Okay, just look at the y-axis. So it went from -3, I'm back to right now, to -1. You go from least to greatest. And so if you want to write that in inequality form, -3 less than or equal to y less than or equal to -1. Okay, so that's how you do number 2 when there's a restricted domain. I will tell you that on the you do part, 1 and 2, they're not restricted domains, okay? So pay attention to see if it's restricted. Most of the time it's not restricted, so most of the time you can just put all real numbers. So when in doubt, go with that. But this is what it'll look like when it's restricted because it's not going off the graph. So number 3. Write an equation of an absolute value function that has a max value of 4 and an axis of symmetry at 2. So remember, what is it? Quadratic functions where you have this a times x minus h plus k, x minus h squared. Well, imagine that being for absolute values. Just take away the power of 2 and then take away the parentheses and put what am I trying to say? Put the absolute value bars. All right. So write an equation of an absolute value function has a maximum value of 4. So that's the k. So I'm gonna write f of x equals and an axis of symmetry at 2. That's the h, because remember the vertex is at h comma k. So I'm gonna just put x minus 2. And then plus 4. That's really all it's asking. You got to think back to how you learned this the first time and then compare it to the quadratic functions, and it's pretty much the same thing, just rather than having the power of 2, you have these absolute value bars. Now, I didn't do anything for a because it didn't give me enough information, so I'm just going to put an a here, and then we'll put a note on the side that a can be any number, all right, because it didn't give you multiple points. If it said it needs to pass through this point, then we'd have to figure out what a is. But because it didn't do that, we can get away with saying a can be any number, all right? So, yeah. Let me lock this in place, and then let's move on to number 4. Write the equation of an absolute value function that opens down, has a vertex of -3, 7, and has the same vertical stretch as 2 absolute value of x. All right, so I'm going to use this same formula, pattern, whatever you want to call it. So, this is at h, comma, k. And it opens down, so that tells me a is going to be negative. All right, so I'm going to write, and then it has to have this 2 there, right? So I'm going to write f of x equals, if you want, just put negative a. I don't know. I feel like that works, right? And then we have, oh, no, not negative a, negative 2, sorry, because it has to have the same vertical stretch as that, so that's where the 2 is coming from. And then we're going to have x, and then it's normally minus h, right? So if you minus a negative, it turns into plus, and then just put plus 7 on the outside. So problems like these two, if you're trying to do these in the graphing calculator, you would have to graph the answer choices and then find the vertex. That's menu 6-2 or menu 6-3, depending on if it's a min or a max. And then if it has the same vertex, then the vertex has a max value of 4 in the y-coordinate, and then x is symmetry of 2 in the x-coordinate. So you just look for that in your answer choices. You look for that in the graphs, okay? So that's how you would do it using the answer choices, going backwards, so to speak. Number 5 is the same thing. You can graph the answer choices and then figure out what has a max value of 5 and x symmetry of 4. It's going to be a lot like number 3, actually. So max value of 5, that means it's going to end with plus 5. X is a symmetry of 4, that means it's going to have x minus 4 on the inside, because it's always x minus h. And then you just have f of x, and then it didn't give you any information about a, so we can just say any number. All right, it didn't say if it opens up, down, vertical stretch, compress. It didn't say anything like that. So that's all we're looking for there. And so, like I said, if you're graphing equations, you need to graph an equation that has the same vertex as what's given to you. All right, so the rest of these, stay tuned for part 2, because I'm going to show you how to do them in the graphing calculator. All right, so thanks for watching. Bye.